Hi everyone and welcome. In this explainer, we're going to get you totally up to speed on a key topic for your AQA A-level environmental science course, the impact we humans are having on the water cycle. We'll break down everything from the natural system to how we can manage it all sustainably.
So here's how we're going to break it down. First, we'll get a picture of the world in balance. Then we'll look at the human fingerprint on that system. After that, we'll dig into the consequences of those changes and finish up by exploring how we can manage our water for the future.
Okay, let's dive right in. To really get our heads around how the hydrological cycle is being changed, we've got to start with the basics, right? How does it all work naturally when it's just left to its own devices?
Right, let's start with a bit of perspective. Check out this number. A staggering 96% of all water on Earth is found in just one place, the oceans. It's an absolutely enormous reservoir. But the catch, of course, is that it's salt water, so we can't really use it for most things.
So you can see the oceans are massive, but have a look at how the rest of the water is distributed. Look at those tiny percentages for things like the atmosphere and rivers. But here's the thing. Even though those reservoirs are small, they are incredibly active, and they're the parts that are moving water around the planet really, really quickly.
Now, this right here is an absolutely crucial concept for your A-level. The natural water cycle exists in a state of balance called dynamic equilibrium. It just means that the amount of water evaporating is balanced out by the amount falling as rain or snow. So the system is always moving, but the overall levels in each part stay pretty much the same.
And that idea of movement brings us to another key term, residence time. Think about it. A single water molecule might only hang around in the atmosphere for about 10 days before it rains out. But that same molecule could spend up to 4,000 years in the deep ocean. This massive difference is key to understanding why some parts of the cycle react to change so much faster than others.
Okay, so we've got our balanced system. Now let's look at how we, humans, are throwing a spanner in the works. We call these anthropogenic activities, which is just a fancy word that means they come from us. We're basically changing the speed of different processes, and that messes with the residence times and the amount of water in all those different reservoirs.
This table gives us a great snapshot of the main ways we interfere. Deforestation means less water is caught by leaves and released by trees. Building cities creates surfaces that water can't soak into, and abstracting water means we're literally pulling it straight out of rivers and the ground. Every single one of these actions is tipping those natural scales.
Let's really see this in action with a comparison. Picture a forest floor. It's kind of like a giant sponge, right? Rain falls, it gets caught by the canopy, and what trickles through soaks slowly into the soil. But now picture a city, covered in concrete and tarmac. There's nowhere for the water to go, so instead it just rushes over the surface as really rapid runoff, heading straight for our drains and rivers.
So we've messed with that dynamic equilibrium. What happens next? When that balance is lost, what are the actual, real-world consequences? Let's have a look.
Well, the impacts link directly back to the changes we just talked about. All that super fast runoff from cities. That massively increases the flood risk for people living downstream. Cutting down forests can actually change rainfall patterns downwind, leading to droughts. And when we take too much water out of the ground, the water table drops and surface features like wetlands can just dry up.
And if you want a really stark, almost unbelievable example of this on a huge scale, look no further than the Aral Sea. It used to be the fourth largest lake in the world, but the two main rivers feeding it were diverted to irrigate massive cotton fields. The result? It has shrunk by 90%, leaving behind what is now basically a toxic, salty desert. And these problems aren't just environmental. They can get political and fast. As this quote points out, when different countries have to share the same river, think about the River Nile, which is shared by 10 nations. Disagreements over building dams or taking water can become a massive source of tension. And that risk just grows as populations get bigger.
Okay, that all sounds pretty grim, I know. But the good news is there are definitely things we can do to manage our water more sustainably. So what's the plan? This brings us to the strategies we can use to secure our water future.
So, when we look at the solutions, they generally fall into four main categories. We can use water more economically to cut demand, we can get smarter about how we store it, we can manage entire river catchments more holistically, and we can look at exploiting new sources.
First up, and honestly this is probably the most important one, just use less water. It sounds simple, but it's huge. Things like water meters actually make people think about their usage. Clever tech, like dual flush toilets, makes a big difference at home. And in farming, switching from giant sprinklers to targeted drip irrigation can save incredible amounts of water.
Now, this is a really smart piece of engineering. During periods of heavy rain, when rivers are high, instead of just letting all that extra water rush out to sea, we can actively pump it underground to top up our natural reservoirs, our aquifers. It's literally like putting water in the bank for a dry spell.
And this is a great example of how sometimes the best solution is to work with nature, not against it. It's simple logic, really. If cutting down trees causes rapid runoff and flooding, what do you think planting them does? Exactly. The trees act as a natural brake, slowing the water down, creating a more regular river flow, and stopping valuable soil from being washed away. All right, to wrap things up, I want to leave you with a question to mull over, the kind of thing you might see on an exam paper. When you think about the UK, with our crowded island and our increasingly bonkers weather patterns, which of these strategies do you think is going to be the most critical for us over the next 50 years? That's all for this explainer. Thanks for joining me.